So we'll go ahead and record. There we go. I'm ideally getting a better camera next year. Oh. All right, so we're skipping a little bit. I talked to my my boss, if you will, at UMKC, and we skip a couple chapters. So the direction I was heading, I spent like 3 hours a couple weeks ago preparing for the one lecture. She said we could skip, so we're skipping. So it was kind of a waste of time. So we're going to jump into lecture 44. It's called Sequences and Summation Notation, or sigma notation. First thing we have to do is have a definition. And the definition is an infinite sequence. So we know what infinite means, right?
Yeah.
What's infinite mean?
Forever.
Yeah, it goes on forever. Okay, so infinite sequence, so we have that word sequence. We're going to notate it A sub n. Is simply a function. Remember, f of n stands for function, right? Simply a function where. Okay, so define for me what's a function.
Something with a variable.
Something with a variable. In fact, we typically use x and y, right?
Yeah.
So it's where every x has
A y.
exactly, or at most, one y.
Yeah.
Every x has at most one y. Okay, so it's a function where the domain. Okay, so what's domain?
The x.
Possible answers for x.
Yeah.
So like if we're talking about in basketball, one shot, one release of shot, you can have a domain of 0, 1, 2, or 3, right? Because you could miss it if you're shooting, it's 0 every time, right? If I'm shooting, it's 3 every time because I make every. Okay, but I can't do one shot and make 5.
Right.
I can't make one shot and make a half. So it's all the possible values for domain. For the domain. So it's an infinite sequence is a function where the domain, that means everything we put into it, okay, is the set of perfect. And we are recording for people who are actually here. So, domain is the set of positive integers. Do you happen to remember, I don't know if we did at the beginning of this class, we did in Algebra 2, what letter of the alphabet, capital letter, represents integers? Like N stands for natural numbers, R stands, that funky looking R,
That's
was for
all
real numbers. Do you remember what letter it was?
I
Okay, it's a weird one. It's a German word, it's the letter Z.
know. Oh, I was actually just about to say this.
So Z, and I put a little plus sign to show that it's all the positive integers. Okay. So Z plus, little side. Okay. All right, so then the second definition, finite sequence is what?
Not going on forever.
It's not going further. It's only, the finite sequence is only the first, and then we use the letter N. N finite sequence is only the first N positive integers. So like maybe I want to go from 1 to 5, the first 5 numbers in the sequence. Okay. So an infinite sequence, is a function Same thing we were talking about, it's a function, it's every x has at most one y, but the domain is only positive integers. So like with the function, I can put in all reals usually. I can put in 1/2, I can put in 0.3, -16. Okay, this one I can only put in 1, 2, 3, 4, 5. Notice what a number is also not included. You can't use 0. That's a positive integer, so start with 1, go 1, 2, 3, 4, and so forth. Okay? So, for example, good morning, that's say again? That's as far as we're going. So for example, we have a very, very famous sequence. Okay, maybe you guys remember this one. It starts off with 1, 1.
Oh, I should know
The next number is going to be, it always starts off with 1, 1.
this.
Next number is going to be
2,
2.
4, 8,
Nope.
6.
Nope.
It's not that.
Nope. This one's 2. What's the next one?
2,
Nope.
8,
Nope.
3.
3.
It's 3 and 5,
5.
8, 13. It's not the more. You're on 21 this time. You're adding.
How am I finding the next? It starts with 1, 1. How do I find the next term?
Add by the previous term.
Add the previous two. Very, very good. Do you know what the name of the sequence is?
Geometric.
Oh, no.
Arithmetic.
I'm gonna go up to here. Is that okay?
Yeah. I just need the bottom of that.
Well, we're gonna talk about geometric and arithmetic sequences later. This has a very specific name. Okay?
This
called-
one does?
It's named after an Italian guy.
I forgot.
Fibonacci.
Yes.
That's a Fibonacci sequence. So we're using that as an example of what we call a recursive sequence. Okay? This is an example of what we call recursive. Is that the word I'm looking for? Yeah. Recursive. There we go. Ooh, thought I was spelling wrong. So this is an example of recursive where the only way to find the third term is to know the first and second, know the previous ones. Okay, it's the only way to find the next one is to know the previous ones. So
Isn't there one where you multiply the previous one to get the next one?
that would be a geometric.
Yeah.
Arithmetic is where you have a common difference. Geometry would have a common ratio. This one is recursive. There is no multiplier thing or adder thing, nothing like that. Okay, in fact, we're going to refer to these. This is the first term, right? So our variable for this one is going to be a sub 1. A is just simply stands for the term, the term. And then the 1 tells us which one. So like this would be a sub 2. This would be a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and you get the idea, right? Okay, so if we were to turn, now we know that this Fibonacci sequence is infinite, it goes on forever. But let's turn it into a finite. And let's say we only want the first n terms. Okay, actually I need to. What would be the last term in the sequence? If this is the first one, A1, A2, A3, A4, A5, A6, A7, A8, what would be the last one? Well, how many terms do I want? The finite is the first n terms, right? So the last one is going to be A sub n. Okay? To whatever term we would actually get to. Well, I should have written it down here. A sub n. Okay. So then, what's the term right before it? Let's spread this out a little bit more.
A of 1.
If this is, the last one's A sub n, what's the one right before it? Go ahead.
A1 minus A of n.
No? Yes.
A of 1 minus n.
Other way around.
A of n minus 1.
N minus 1. It's the one right before it. Okay. What's the one right before that one?
A of n minus 2.
So we see that notation where A sub n is my last one. The one before it is n minus 1, the one before it is n minus 2, and so we go back up. So then for this particular function, I would say that any A sub n where n is greater than or equal to 2, I'm sorry, not equal to, just greater than, as long as n is greater than 2, which means it can start at 2.1?
Yes.
No.
I
Or what's the domain for n? The domain is only positive integers, right?
Yeah.
So n can't be 2.1.
Yeah.
So what's the first number it has to start with? Has to be 3. And then 4, and then 5, and 6. Okay? So this particular equation, whatever n sub n, a sub n is, it's going to equal a, the one before it, n minus 1, plus a of n minus 2. And that's my equation, or formula, if you will, for the Fibonacci sequence. So for instance, if I wanted a sub 9, which is the next one in the series, I would have to do a sub 8 plus a sub 7. And that would give me the next value in the sequence. And the only way to do recursive, so the only way to know the 9th term in the sequence is to do what? I have to know the previous term, a to the 7th. So in a test, if I said, here's your sequence, I would like you to find a of 100, you would have to literally write out the first 199 terms in order to find 100.
Would you make us do that?
I will have you do large ones like that, but we're going to do it with geometric and arithmetic sequences where there's a formula. We can jump straight to it. Recursive formulas you can. It's just like you got it all. Which is why we like those with you multiply by 2 or you multiply by 2 subtract 1 or whatever formula. Right.
Also.
So no, I will not do those recursive and say, hey, I may say list the 10th one or the 11th one, but I wouldn't do 100. It's nuts. Yes.
Also, since the test is over, what was the bonus question? Like, what
He's
was?
not taking it.
Oh.
So
Yes,
the
I
bonus,
can.
the bonus answer is, I'm not telling you.
Yeah.
I have the customs to be careful.
So,
Alright, that's all right. Alright, so, let's see here. So, if we have sequences, are we good? Did we get all that?
Yeah.
Okay, alright, good. Well, that was nice. That's all right. Okay, so, let's give you an example of a sequence equation. Now sequences come in all forms, arithmetic, geometric, all sorts of things. Let's just say, for example, I give you a sub n equals 3 times n plus 4. What does that kind of look like? Based upon our previous experience of math, what does that kind of look like?
it looks like something that says, if this is this, what it's like the. Wait. Never mind. I looked at it wrong.
Right. What does it kind of look like?
Looks like a variable.
If I changed a and n, a sub n and n, something different.
If you change it to x, it would look.
Wouldn't it look a lot like f of
Factor.
x equals 3x plus 4?
So it would be a linear equation.
And that's a linear equation, right? That's a linear function. We've done that forever. All I've done here is I've changed the letters, and there's a reason why I changed the letters. Okay? Let's say we want to find, I don't know, give me a number. Find,
7 and 8.
oh, let's not go that far. Find the first
4.
4, there's a good one. First 4 values in the sequence. So this one is not recursive because I don't need to know a of n minus 1 or a of n, a sub n. I just have to know n, what term am I looking for. Okay, so to find this, I'm going to find the first term, a sub 1, is simply, and then what do I do for n?
Do the same.
Just like over here, if I said find f sub 1, you simply plug 1 in for x, right? So if I'm finding a sub 1, you simply plug in 1 for n. So 3 times 1 plus 4. It's going to give me 7. Okay. Now, once again, this is not recursive. I don't have to know a of 2 or a of 3 or a of 4. If I just want to find a of 2, I can just jump straight to it, right? And what is a of 2?
10.
Oh, I used 7. get that so fast?
You just add 3,
And where do you see 3 in my original equation?
up there.
Yeah, you see the slope is my rate of change, right?
Yep.
It's just changing by a value of 3. So we have a connection to functions and slope inside the sequences. So 3
That's how
times
it's
3
mapped.
plus 4 equals 13. And we can continue in that pattern.
Yep.
Okay? So there's a good connection between sequences and functions, but I want you to see the difference. Okay? Can I erase part of that? Are you good with that?
Yeah, I'm good.
Well, I hate to erase it because I'm gonna post these notes, but let's come down here, let's do this. Let's go ahead and let's graph my function 3x plus 4. Going back to algebra 1, right? Graphing a linear function. Pre-calc kids hate it when I say let's go back to algebra 1, but we do it so much. How do I graph 3x plus 4?
Slope.
So before my slope, I have to start with what?
Your y-intercept.
Y-intercept. In this case, mine, you got 50-50 shot. Which is my y-intercept? 4. Very good. 1, 2, 3, 4. And then what's my slope?
3.
3. So that means
3.
up 3.
Over 3. Over whatever.
Over 1.
Oh, my fault, my bad. Yeah.
Up 3 over 1. 1, 2, 3 over 1. Or down 3 and over 1. Down 3 over 1. Down 3 over 1. Now, with a function, what did I do to those points? I connected them. And someone tell me, what does it mean when I connect these points?
They're all positive integers.
Nope, they're not all positive integers. In fact, there's a fraction. Most of them are fractions right through here. These are all fractions, all decimals. So any number on that line will make this function true. And I can have decimals, I can have fractions, I can have negative values. Every number on that line makes it true. Let's graph the sequence. Okay. So here I'm going to graph the sequence. Okay. Let's go in green this time. I'm going to do the same place, start at 4. 1, 2, 3, 4. I'm going to go 1, 2, 3, and over 1. 1, 2, 3, and over 1. Can I go down here? 1, 2, 3, and over 1 here? Can I put that point on there? Can I plot that point?
Is it in the sequence?
It is. It's down 3 over 1. Is it a positive integer? Is x a positive integer?
Yes.
What's x value here?
2.
The x value right here?
Negative. Or -2. Oh, shoot.
Isn't that -1? My line should have the x was down the line.
Oh, yeah.
Okay, so I can't plot that point because n can only be positive integers. That's not a positive integer. So I gotta get rid of that. Whoops. Hang on.
So we don't put the arrows in?
No. In fact, I have a point up here also that's not right. So I have to get rid of. What other point did I get rid of?
That one, the first one, could be 0.
Yeah, the y-intercept.
Yeah.
Okay, I can't have, oops, is it here, right?
Yeah.
I can't have the y-intercept because that's where n equals 0 and our domain is positive integers. So I have to start here. Okay, and then do I connect them?
No.
No, we can't connect them. Okay, so I have to go 1, 2, 3 over 1. 1, 2, 3 over 1. And I don't draw a line because those are my only values
Yeah.
for this sequence.
I understand it now.
Okay, does that make sense?
Yep. Makes sense.
It has to be positive integers only.
So it'll only be on the right side.
It'll only be in the positive. It's only in the first quadrant.
Right.
Now, that may not be true. It could be in the fourth quadrant if you have negative values.
Right.
But my domain has to be on this side. First and fourth. Okay? All right, let's see here. Okay, let's go back to, see, do we do Roman numeral 1? Then we just kind of see some definitions. So Roman numeral 1. Let's talk about recursive sequences. Now remember, recursive, you have to have what? It's based upon finding what?
The previous one to find the next one.
Very good. So, recursive, by definition, the nth term of the sequence, hope you don't mind if I abbreviate a little bit. My handwriting is bad enough, so I try to abbreviate a little bit. The nth term of a sequence is found using the previous term or terms. So the nth term of a sequence is found by using the previous terms. Now, how do we notate those previous terms?
A sub nine.
Well, this is a sub n. The previous one is going to be a sub,
Oh, n minus one.
and the previous one is going to be
N minus two.
n minus 2. The previous one n minus. What's going to be the next one called?
A n plus one.
N plus 1. A to the n. Don't let that notation scare you. A sub n just means any random term. And then n minus 1 will be before it, and plus 1 is the one after it. Alright, so an example from what you'll see for homework type questions. It's going to say something like, find the first 4 terms. Find the first 4 terms given a sub 1 equals 5. Is that the right example? Yep, there we go. A sub 1 equals 5. A sub n is going to equal 3 times a sub n minus 1 plus 2 for n greater than or equal to 2. So we're given 3 things. We're given a first term, we're given a formula to find the next one using the recursive formula, and then we're limited to n has to be greater than or equal to 2, which means you have to do the first one. Okay, so a sub 1 we know is 5. What's a sub 2? How would you find a sub 2?
Plug in 2.
3 times, what am I going to plug in for a sub n minus 1?
3 is n. Or 2 is n, I'm sorry. No. 5.
Say it again?
5.
5. So if we write this out, a sub 2 is going to equal 3 times a of 2 minus 1 plus 2. So we have the second term is going to be equal to 3 times the first term, which is 5, plus 2. So my value is
2 plus 2 is 17.
17. So how would I find a sub 3?
Plug in 17.
There you go. So it's going to be 3 times a sub 3 minus 1 plus 2. Or a sub 3 is going to equal 3 times 17 plus 2, which gives me an answer of
51 plus 2, 53.
53. And then a sub 4 would be equal to 3 times a sub 4 minus 1 plus 2. So just plug your answer into the next one. Which equals
159 plus 2, which is 161.
very good computation. Hopefully you use that same computation skill in the last class.
I do not. No.
So then our sequence is going to say 5, 17, 53, 161.
I have a question.
Yep.
So when you did just from A of one?
Yes, because A of two minus one is the same thing as two minus one is one, it's A sub one.
Yeah.
So A sub one, they have to give that to you.
Oh, okay.
Then you just plug the 5 in and then you just go from there. Just keep plugging in your answer to the next one.
I was just a little confused how two minus one is five.
How two,
Minus-
oh, two minus one is one, which means A sub one.
Yeah.
And there's A
That,
sub one.
that makes more sense than two minus one equals five.
Yeah, beautiful.
So is there like any way, so say you give us the first two, or first three, I say, could we find a pattern from there?
Can you find a pattern?
No.
I don't, it doesn't look like it.
Just making sure.
Well, it's not arithmetic.
Yeah,
So there's not gonna be a common difference.
right,
This is up by 12, this is up by 34,
yeah.
okay? It's not gonna be geometric because there's not a common, you're not multiplying by 2, multiplying by 3, multiplying, so it's recursive.
Right, okay.
You can look for a pattern,
I
depends
will
on the
find
function.
one. I will find one.
depends on the function. Alright, so you try one.
Alright.
By the way, what if I said in here, rather than find the first 4 terms, what if I just said, find,
A of seven.
I was gonna go A of 5, make it a little simpler, but what, I just say A of 5 or A of 7. What would you have to do?
You have to find the first four.
Find the first 4, then find the fifth one, or find the first 6, and then find the 7.
Yep.
Alright, you try this one. So what am I gonna give you?
The first
Okay.
two, first one.
Say I give you the first one, A sub 1 equals 2. Oh, no, hang on. I can't copy the stuff out of my notes. A sub 1 equals 3. A sub n is gonna be equal to 2, here's where the 2 comes in. 2 of A sub n minus 1 plus 5 for n is greater than or equal to 2.
I have a question about the.
Find A sub 4, and then I'll answer your question. Find A sub 4. What's your question?
What is the n is greater than, I have a question.
Huh?
What is that for?
What the n is greater than or equal to 2? This one here?
What's it for?
Okay, so, state of confusion, no, I'm just kidding. It's only there to tell you, I've given you the first term, so we can't find the first term with this particular formula. Because if I was looking for A sub 1,
You write down.
the first term, that would be 2 times A, what's 1 minus 1? 0 plus 5, how do you find A sub 0? Can't.
Okay.
So all it's saying is, well, I've given you the first one, for everything else beyond this, that's how we find it, that's all.
Alright. So for the first one,
That, it is, it's just saying that is, those are the only terms you can use.
Correct, so let me give you an example. Do you remember back when we did the function f of x equals 1 over x? Okay, rational function. So what can x
yeah.
not be equal to? What was the no?
zero.
So we always roll over here, x cannot be 0. It's the limitation on your domain. This is the same thing, it's just your limitation on your domain. Alright, I'm sorry, Cameron, what was your question?
So for the first one, so it would be 2 times A of 5 minus 1 plus 5. Or 3, sorry. 2 times A of 3 minus 1 plus 5. Yeah, like that.
So, what's in here, remember, this is just 2 times A of, I'm looking for the second term, so 2 minus 1. So that's just saying A sub 2 is going to equal 2 times A sub 1 plus 5. So you simply plug in 3. 2 times 3 plus 5. That gives you your second term, I want the fourth. Okay, yell at me when you're ready.
I'm ready.
There's 1.
I am
2 people. Damien, you good? Cordell, you good? Alright, so if the ace of 2 is going to be 11, ace of 3 is going to be 27, so ace of 4 is going to be equal to what?
59.
59. Good?
Yep.
Okay, so topic number 1, recursive. That's what it looks like. That's what the formula gives you. You have to find them in order. We're good with that? Number 2. I got 1 yep, so I'm going to keep moving. Number 2. This is a notation you've seen before in algebra 2, and that's factorial. You do not have to factor. Factorial notation is simply the exclamation point.
Oh.
So what does the exclamation point mean? What if I give you, let's go general first. What if I give you n factorial? What's that going to mean?
It's really big.
Okay. Let's go back to something mathematical. What if I give you 3 factorial? What does 3 factorial mean?
And it's a factor.
No?
3 times 3.
You don't remember this?
I kind of remember it. I remember factorial notation. I don't remember the actual.
Because they just keep talking out loud like they're trying to guess. No idea? No idea? Okay. So all it means is 3 times 2 times 1. So 3
Oh,
factorial
it's
is simply you're
every-
multiplying
Every number before it.
all of the integers.
All the
Have a good day.
All the integers.
All the integers, all the way down to 1. So this would be equal to 6. So if I have 4 factorial, that's 4 times 3 times 2 times 1. 24. 5 factorial. You get the idea, right? So what would n factorial be? Well, it's going to be n times, what's the number right before n?
And -1.
Times,
And -2.
you get the idea?
Yep.
All the way down to 1. So that's what factorial means. Now, there is a note here. We have a special definition. Wait till you get to like advanced statistics or whenever they teach. I can't remember what they teach this to you, but
I was about to say, isn't this used in statistics?
it is. It is. Probability a lot. 0 factorial. Now you would think that 0 factorial would be equal to what?
0.
You would think so, right? But a special definition. It's kind of like anything to the 0 power. What does anything to the 0 power equal? What's it equal?
1.
1. Anything to the 0 power equals 1.
Oh, sorry.
So, but by this one, there's a special definition where it just equals 1. Anytime you see 0 factorial, it means 1. Okay? All right. Then the other thing too is, it's kind of like a parenthesis. The exclamation point only affects what it is next to. For example, and you'll see what I mean by this real quickly. If I give you 2 times 3 factorial, okay, kind of going back to that PEMDAS, before I multiply by 2, I have to take care of the exclamation point. So you think about PEMDAS, right? P is parentheses, right, or grouping symbol. This is exponents. This is multiply, whoops, and divide, add and subtract, right? Well, where would factorial be inserted? infinity. It's kind of like parentheses. You kind of have to think of it always as a parentheses. You always do that exponential part first, or that factorial first. So in this case, what this means is 2 times 3 times 2 times 1. Not 2 times 3 and then 6 times 5, 6 times 4 equals 1. Now, if we wanted that, we would have 2 times 3 and then factorial. So now I have those parentheses and then do 2 times 3 first. Okay? There's a difference between those two. And when we get to some notation when it comes to permutations and combinations later on, that's going to come into play. Because we're going to have like n minus 1 or n minus r factorial. Okay? So just keep that in mind. Okay? So let's do a couple of things with this. Okay, let's see here. Right, here's an example. Right, the first, I said 4 terms, let's go with 4. Terms given a sub n equals 2 to the n over n minus 1 factorial. So write the first 4 terms given a sub n equals 2 to the nth power over n minus 1 factorial. So my first question, Damien, is this recursive?
No.
Why is it not recursive? Because you interjected into my conversation with Damien.
2 is less than 2.
Nope.
It's a fraction.
Nope.
Never mind it. I don't know.
Yes.
It's exponential.
Nope. So think about 2 to the n over n minus 1. Think about recursive. What did recursive have in its equation?
A1.
A n
It
minus
doesn't
1.
have a minus 1.
So it was asking for the previous term, right? This one, this notation, it just has what?
It just has a minus 1. It doesn't have a of a
It,
minus 1.
and it just has n.
Yeah.
So I'm not looking for I need the previous term, I just need the number n.
Yeah.
Okay, so this is not going to be recursive. Okay, so we can jump.
Wait, so is this even a sequence?
Yes.
Well, because of the notation.
So I could actually jump to this and say, what's the 100th term? I could just
Yeah.
start off. Forget the first 4, just give me the 100.
Yeah.
N would be 100, this would be 99, and you'd go on right.
Right.
Okay? So it's kind of, so let's find the first 4 terms. Let's do a sub 1. Okay, so what am I going to put in every time I see n? 1. So it's 2 to the first over 1 minus 1 factorial. Okay. So, oops.
52.
So 2 to the first power would be 2 over, what's on bottom?
0. Or 1.
0 what?
Factorial.
0 factorial, which is 1, so the answer is going to be 2.
Yeah.
Okay. A sub 2. What's a sub 2 going to be?
4.
So on top it's going to be 2 squared, and on bottom it's going to be
Or 4.
4 over
1.
1 factorial. Which gives us 4. Okay? So 2, 4. Any guesses on what the next is going to be? Let's say a sub 3 is going to be equal to 2 to the third over 3 minus 1 factorial.
So it'd be 4.
It's kind of weird. What's 2 to the third?
8.
8. 3 minus 1 is 2 factorial is, yes,
Yeah.
2 factorial is 2. So 8 divided by 2 is, that's weird. But it's right. What's a sub 4? 16 over 3 factorial.
Oh, wait, no, so it'll be six, so 16 over 6.
16 over 6, which reduces to,
Mhm. 8 over 3.
so is this thing going up or going down?
Down.
Well, it went up from here to here. Now it's going back,
It's a parabola.
potentially, something similar. More than likely, it's, yeah, if we were to graph it. So you start with 2, and then 4, 4, and come back down. And go back up. Although we don't draw it out, we do something like that. Okay?
Oh, it could be a waveform,
Yeah, I don't think so, you have to figure it out to see what happens.
cause it,
And if you wanted to graph it on Desmos, 2 to the x power over x minus 1 factorial, you can kind of get the function, what the function will look like.
can I take a picture of this?
Yes, I'll also post these notes on,
So I have to work none of this down.
I will simply post this as well, so, for Jade and whoever you send it across.
Jake is literally missing.
Now, something that's gonna help you later on, okay, I'm gonna show you 2 things that are gonna help you, yes.
What, I have a question about the first 2 factorials that we is 1 oh no, it's just 1 and then 2. Never mind, I just
Yes.
realized why we didn't
How we gonna-
write those out. Never mind, I just answered that question.
Good, I love it when you do that. Alright, so here's a little bit of a shortcut, although I don't know that you're gonna need it, because I'm gonna show you use the calculator here in just a second. But this is a shortcut to large factorials. This actually helps us in Scalable, okay? So let's say I give you 26 factorial. What would that be?
No idea.
26 times 25 times 24 times 23, huge number, right?
Yeah.
But when we start doing permutations and combinations, we're gonna be dividing. And let's say I'm dividing by 25 factorial. What does 25 factorial mean? 25 times 24 times 23, right? So the shortcut is I could write this as 26 times 25 factorial. Correct?
Mhm.
Because 26 times 25 times 24 times 23, that's just another way of writing it. Divided by 25 factorial. And what happens to those two? They cancel each other out, and my answer is 26. And I don't need a calculator for that. You see how I went from here to there?
Yeah. Wait, so what was the bottom number again?
25 factorial.
Okay, it just looked like 125 factorial.
It becomes one because it cancels.
Yeah.
25 factorial on top and bottom cancels. Let's try one a little smaller. Let's do 9 factorial. Now 9 factorial is still pretty big, right?
Yeah.
Yeah, I don't know.
Nine
Not
times
even
eight
close.
is,
Divided by 7 factorial. Okay, so 9 times 8 times 7 times 6. In fact, if we wrote it out, we'd have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 7 factorial. 7 times 6 times 5 times 4 times 3 times 1. What happens to all these numbers?
They cancel.
So it's like saying 9 times 8 times 7 factorial over 7 factorial.
So 9 times 8.
So the answer is
76.
70. Because those would cancel.
That is kind of
A
cool.
little bit of a shortcut. You're going to be able to use your calculator for these, but that's a little bit of a shortcut. Especially if you're on a test or you're Scalable going fast. Okay? Okay. Let's actually grab a calculator real quick. You can use either one, the blue one or the yellow one. I'm going to show you the yellow though. It's a little more complicated.